determining limits at plus or minus infinity. The most important thing here to realize is as x is getting extreme, so x is going to plus infinity or minus infinity. That's not a billion, that's not 10 billion, that's not a quintillion. That's far beyond our imaginations. X is getting extreme. Well, the most important concept here is as x gets extreme, away from zero, either to the positive or negative side, the graph conforms to the horizontal asymptote. In other words, the graph follows the horizontal asymptote at extreme values of x, which means we have to know these rules. Bottom heavy, y equals 0, equal ratio of lead coefficients. Top heavy, no horizontal asymptote. So our graph is going, for this last case, our graph is going to be either increasing without bound, up, or down, down, left or right. So this will be our interesting case where there's no horizontal asymptote. If I see a limit at infinity, I'm just thinking top heavy, bottom heavy are equal. Well, this is bottom heavy. So I know that the limit is 0. The y value is going towards the horizontal asymptote. Bottom heavy, horizontal asymptote, 0. The y values are trending towards 0. Limit at infinity. I think top heavy, bottom heavy are equal. Well, this one is equal, so the limit will be 3 over 1, or simply 3. The ratio of the lead coefficients. As x gets big, the y value goes to the horizontal asymptote. There's nothing written here, so I can say x to the 0 on the bottom, because x to the 0 is 1. I can add that in. If you don't want to add that in, fine, don't. Notice, though, this one is going to be top heavy. If it's top heavy, there's no horizontal asymptotes. So you might think of this as the limit does not exist, but we can get more specific than that. All we're going to do is look to the term with the highest power, and we're going to substitute in our negative infinity. Well, negative infinity, or a really big number cubed. So maybe this concept of infinity is beyond your imagination. Put in 10 million, negative 10 million to the third power, negative times negative is going to be negative. So our graph is heading down towards negative infinity. We can almost consider that a one-sided limit. Where's the trend in y? It's going off the charts negative. So a graph of this actually looks like this. You can see as x goes to the negative side, y is going off the charts negative. So the limit does not exist. You can see that y is heading towards negative infinity. Don't forget, when we're finding the limit, we're looking for the trend in y. And this last one is a case where we're equal, so we go to the ratio of the lead coefficients. That's where the y is going, because that's where the horizontal asymptote is. Here are some more examples of limits at infinity. Again, when we have limits at infinity, we're thinking top heavy, bottom heavy are equal. I recognize that it's a special case where the x is going off the charts positive. This is top heavy. So what I'm going to do is I'm just going to concentrate on the terms. Now, terms are separated by pluses and minuses with the highest exponent. So it's 2x to the third over 3x squared. And I ask myself, is there anything I can do to simplify these? Well, these cancel to leave me with x to the first. So this is 2/3 times x. And I'm taking the limit as x goes to positive infinity. So I can substitute a really big number in there, like 10 million. 2 times 10 million divided by 3 is a big number. So we're heading to positive infinity. As x, this graph happens to look like this. As x gets really big this way, you can see the y's are heading off the charts positive. Remember, we're looking for the trend in y. So what did I do here? If I see it's top heavy and the limit is going towards infinity, I just look at the terms that are involved with the biggest exponents. I separate them out because they will dominate our graph as x gets bigger and bigger and bigger. I try to simplify that. Here's the simplified expression. And then because this is going to positive infinity, I substitute a really big number in there and see what's happening to the y. Well, the y is getting bigger and bigger and bigger, so it's going off the charts positive. What's interesting with this second problem is the biggest exponent is not found with the first term. So you sometimes have to do a little work to find it. Bottom heavy, y equals 0. So our limit is 0. Our limit is not y equals 0. Our limit is just 0. Here we have equal. So we go to the, I recognize that the limit is found at negative infinity. So our top heavy, bottom heavy equal rules take over. So the limit will be 8 over 2. I see it's equal. I go to the lead coefficients, or 4. It's not y equals 4. The limit is 4. Here we have top heavy, a limit at negative infinity, and it's top heavy because that will be x to the first. So again, I use this technique. I just separate out 5x squared over x. Then I simplify to give us 5x. Now with that simplified expression, I substitute in a really big negative number. As x gets really big negative, 5 times a really big negative number is really big negative number. So the answer there is going to be negative infinity. And if I graph this, the graph does look like that. Look, as x goes to negative infinity, y is going off the charts negative. Here are some more examples of limits at infinity. As soon as I see infinity or negative infinity or infinity, I'm thinking top heavy, bottom heavy are equal. I've got to know my rules. So here we have top heavy. So as soon as I see that, I'm going to pick out the terms 7x to the fourth over negative 8x squared. I'll pick out my lead terms. Then I'll try to simplify. So this will be 7x squared over negative 8. Now, as x goes to infinity, a big number squared is positive. I'm sorry, this is not that. This is 8, not like that. So as x gets bigger and bigger and bigger, a number like 100 squared is a big positive number, times a negative fraction will give us negative infinity. So careful there, even though that number was positive, we had a positive number squared times a negative will give us negative infinity there. X is heading towards negative infinity. Top heavy, bottom heavy are equal. Well, look, you could get fooled and call it equal, but it's actually top heavy. So I pick out my lead terms. Even though this isn't the first term written, it's your lead term, minus 8 over x squared. Now we can simplify this to negative 7 over 8. X to the 30 minus 2 is x to the 28th. Now, a big negative number to an even power is a positive number times a negative will give us a negative infinity. That's where the y is trending. Here, top heavy, bottom heavy are equal. It's top heavy, and I'm just going to be taking out my lead terms. So x to the third over negative 8x squared. Can I simplify? Yes. Gives me x to the first over negative 8. Now, what did I do? I said, well, these cancel and leaves us with 1 there. Here, up here, I said 2 goes in, 30 minus 2 is 28. So I'm using this rule. X to the a over x to the b is equal to x to the a minus b. That's what I'm doing to get this simplified version here. Now, if I am going to negative infinity, a big negative number divided by a negative number is actually going to give us positive. We have to know negative divided by negative is positive, and also positive divided by positive is positive. That's the only way we're going to get positive. If the numerator is negative and the denominator is positive, we'll get negative. If the numerator is positive and the denominator is negative, we'll get negative. The last one here, I need to make common denominators. So 4x will give me 4x. I'm really multiplying this by x over x to give me x squared, and I have minus, I'm really multiplying this one by 4 over 4, so I'll multiply by 4 over 4, x squared minus 1. I have to do a little math here. This will give me x squared. If I distribute this now, I'll get negative 4x squared plus 4 over 4x, which I can simplify further to negative 3x squared plus 4 over 4x. The limit is going to infinity, and we are top heavy. So I'm just going to pick out my biggest term there, negative 3x squared over 4x. X squared over x, one of those x's will cancel, and this will simplify just to this, the expression here. If I'm going to substitute in infinity, a really big number times a negative fraction is a negative number. So our y is going off the charts negative there.